Finally, after 2 years of COVID, my manager told me, Bar, you are going to a conference abroad in business class. I was so excited, and I started to prepare my suitcase. And then I discovered my passport has expired. And if you recently tried to renew your Israeli passport, you probably know that it's not so easy to get a new appointment. People are waiting months to get a passport. It has become a national problem. And when you finally do get an appointment, it's somewhere so far, like Afula, but Afula is so far that you need a passport just to get there. When I built this talk, I was worried that until we met, this problem would not be relevant anymore. But it became even worse, and so relevant that it was even in the news yesterday. Okay, anyway, I heard a rumor that probably most of you also heard. Wake up early at 7 a.m., open the Ministry of Interior website, try to get a new appointment, and magic will happen. I did that 4 days in a row, and every single time I got this. And I waited some more, and a little bit more, and after some more waiting, I got this. This service is unavailable. Please try again later. And overall, a really bad user experience. Or in other words, no passport for me. There is probably a good explanation for this. I guess that 500,000 of Israelis who wanted to travel this summer and chose not to go to Afula and also woke up early at 7 a.m. tried to enter the website at the same time, which caused a massive load on the site servers. High peaks that makes website crash can happen to anyone. Even the biggest companies in the industry with the best developers suffered from the same problem. When it was built, no one could predict that this kind of site will become so popular that so many people will try to enter it at once. But it's a reminder for all of us to expect the unexpected. In this situation, I can only imagine that our friends from the Ministry of Interior were probably not using an event-driven design that helped with the processing of many events in parallel. So what do you say? Let's be kind. Let's help them. Let's send them a PR with something like, I really don't know, Kafka? But I am a Node.js developer, and as far as I know, Kafka was written in Java and Scala. There's a situation in my company, Soluto. We are using Kafka in our product, but when this was created, Kafka with Java was the only good option. Today, it's not the case. And you can write services in Node.js that communicates directly with Kafka. And that's our subject for today. Hi, everyone. My name is Cohen, and I'm a Node.js developer in Soluto. Hi, Soluto. As a developer, I experienced a lot of roles. I started as a full-stack developer, then a front-end developer, then a full-stack developer again, and now I'm a back-end developer. What's next? Maybe DevOps? I guess we'll find out in the next conference. And what you should know about Soluto is that we are a Tel Aviv-based company serving as the R&D and Innovation Center of an American company called Asurion. Soluto helps millions of people all over the world manage their tech life over multiple channels. In my team, we are responsible for building and designing flows for high scalable microservices, primarily for a product that connects tech experts with customers. And we are using Kafka every day. So, enough with this buzzword, right? What is Kafka? For those who are not familiar, Apache Kafka is an open source distributed event streaming platform that allows the development of real-time applications. In short, it's a way of moving data between multiple services, and it's capable of handling trillions of events a day. Before we can move on, let's talk about some key terminology that is important to understand. First, producers and consumers. Producers are those client applications that publish events to Kafka, and consumers are those that read these events. Producers and consumers are fully decoupled and unaware of each other, and that's the key factor for the high scalability that Kafka is known for. Kafka uses a structure called a topic. A topic is an ordered collection of events, a queue. That's the database of Kafka. Producers writing events to topics and consumers reading these events from these topics. So topics are partitioned. Partitioning takes a single topic and breaks it into multiple pieces. Each piece can live in a separate node on Kafka. Events that are being produced are being replicated and partitioned in such a way that allows for high volumes of users to use the application simultaneously without any observable lag in performance. In conclusion, wow, it's amazing. Kafka guarantees that any consumer which subscribes to a topics partition will always get that partition's events in exactly the same order as written. That's really cool. We are working with a lot of data and can still maintain everything in order. This means that in the passport catastrophe, each time one of us logged in at 7 a.m., or even 8, 9, or 10, all of those user events should be kept in order so that everybody can get their passport on time. Yeah, you get the passport, yeah, it's okay. In Soluto, we use Kafka for the communication in many of our Node microservices. But the Kafka client is written in Java. And like you, I am a Node.js developer. And I like Node. So why can't I write it in Node? So when I ask this, I heard stuff like, the performance is much better with Java. It's multi-threaded. All of the documentation and courses about Kafka is based on Java. Java has the best Kafka client. It will get the newest feature first. And don't reinvent the wheel. Do what everyone is doing. And of course, the common phrase, if you are a good developer, you can write in any language that you want. But I don't wanna. You saw this, I know. Yes, I am a good developer, and if I want, I can write in any language that I wish to. But do I want to? Do I intentionally choose to write in a language that I prefer less if I know I can do it using Node and maybe even do it better? So what's the problem? Let's write everything in Node. But it just isn't done. Kafka was written in Java. Don't do it in any other language. And yet, despite all of those comments, I decided to take on the challenge and to figure out if using Kafka with Node is an option for us. And I went on a journey to compare all of my options. To do so, I created the best finding game of all time. A battle between 2 Node clients and 1 Java. I want to introduce our 3 champs for today. Kafka.js, Node.RD Kafka, and Java. The purpose of this game was to help us understand if using Node with Kafka is an option for us, and to compare the Node clients against Java in terms of features, ease of use, and of course, the performance. Let's start. I want to introduce the wonderful, the talented Kafka.js. Kafka.js is an open source and a complete reimplementation in 100% JavaScript of the Node client for Kafka. Kafka.js allows you to write the code you want without forcing you to any specific structure. In addition, the documentation was excellent and I managed to write my code really quickly. Yet, I found some limitations. Some Kafka clients have an internal queue that collects produce events and send them every X milliseconds. Kafka.js currently doesn't support it, so it sends every single event one by one. That's extremely slow. With that said, when I tried the produce function of Kafka.js, I saw that I can send multiple messages. But when I tried it, the library threw an exception. Every once in a while, that said that I sent some message that was too big, which is inaccurate. Each one I sent was less than the size limit. Only all of the messages combined were above the limit. Now that we understand Kafka.js a little bit better, let's see some code. You will find my GitHub repo with all of the code in the end. This is how we create a Kafka consumer using Kafka.js. As you can see, few code lines and we are done. We are consuming data from a topic. At first, I used the each message callback, but when I converted to the each batch callback instead, the performance was much better. This was a good reminder that while thinking and writing code for a single event is often easier, you may miss out on performance. In addition, to make it even more efficient, I increased the number of partitions I'm reading from in parallel to 10. And the magic thing about all of this is that, again, we are consuming so many batches in parallel and can still maintain the order of every single event. Moving on, we have the Kafka.js consumer. But what about the producer who is writing data? As you can see, again, it's a straightforward code. In order to publish events to Kafka, you need to create a producer, so simply call the producer function of Kafka.js. The method send accepts multiple messages. Each one contains a key and a value. The message key is used to determine which partition the message will be sent to. It's important because you want to ensure that messages related to the same aggregate will end up in the same partition and will be processed in order. But remember that I told you that there is a problem with producing in a batch? What you can do is to split your messages into chunks and produce each chunk before you can move on to the next one. And that's Kafka.js in a nutshell. Next up, here is one of the controversial ones. Please welcome Node.Kafka. The Node.Kafka library is a Node.js client for Kafka that wraps a native C++ library called Libro.Kafka, which is the library most of the libraries in other languages are based on. And it was built with high performance in mind. This library is older than Kafka.js, and using it was less pleasant. Why? Because, for example, promises are not supported, and I had to register for quite a few event handlers in order to make it work. In addition, I had some problems when I tried to deploy to production using a Docker image based on Node 16. After some reading online, I discovered that above Node.js 10, you need to install a lot of stuff in order to make it work. This wasn't even mentioned in the documentation. So, do we still want to see some code after what I told you? Yeah. Maybe it's crap, but maybe the performance is better than the rest. This is how we create a Kafka.js, not Kafka.js, sorry, a Kafka consumer using Node.Kafka. The important thing I want you to remember from this slide is the stream as a batch property. Using it, you can batch consume messages, which is one of the best ways to increase performance. This wasn't even mentioned again in the documentation. Here's the producer in Node.Kafka. After the ready event is being raised, it means the connection has been completed. And you can call the produce function with stuff like topic, partition, message, and you know. Our last player for today is the most popular one, but not mine. Please welcome Java. As you remember, yeah, it's the evil Java. As you remember, Apache Kafka is written in Java, and because of that, the Java Kafka client is the most popular way to interact with Kafka. Most of the examples online are demonstrate Kafka using Java code, and it has the biggest developers community. But it's not Node. Okay, let's see some code. Just kidding. We are not going to see Java code in a Node.js conference, but if you are curious, you can check out my repo, okay? Okay, to compare the performance, I set up a basic but a reliable benchmark with prod conditions. I deployed each service on Kubernetes with the same resources and the same Kafka config, and I gave it enough CPU and memory to make sure the results will not be affected by the machine quality. For each Kafka client, I created one consumer, one producer, and one topic with 10 partitions. The events I produced had the same value, and a key that was one of 10 random UIDs I created to make sure that the events will spread around evenly across the topic partitions. And lastly, I used batch consuming. Let's see the benchmark code. Each time a new batch was consumed, I called the monitor function, and we will see it in a bit. Before I produce the events, I scaled down to 0 the number of consumers in order to make sure that the results, the consuming time results, will not be affected by the time it takes the producer to produce. Let's see the monitor function. Each time a new batch arrives, we increase the number of messages we read so far and the number of bytes we read so far. And eventually, when the benchmark threshold is being reached, some kind of number that you choose before, we log the amount of megabyte we consumed, the execution time, and the start for 1 second. And now, for the final numbers, spoiler alert, the results are surprising. That's the results of producing 100,000 events at once. The fastest producer was not Java, it was Node.Kafka. You remember the crappy Node.Kafka? Java had the worst producing latency times. But the Java consumer was outstanding and consumed all of the messages in only 40 milliseconds. But at first, it wasn't the case. At first, I used a machine with average resources, and the initial results were totally different, as you can see. Java consume time was 100 times bigger than the results we just saw. But when I increased the CPU and memory, Java could better utilize the available resources, which changed the benchmark results entirely. So just remember, whenever you benchmark stuff, make sure that your hardware always makes an impact. And if you're using a machine with average resources for Kafka, you probably should go with Node. To sum up, the best producer in terms of latency was Node.Kafka, and Java was the worst one. From the consumer side, we saw the opposite results. With all of this in mind, you can use one of these options, depending on what is most important to you. I want to show you an alternative way, what we are currently doing in Soluto, a method for writing services in Node.js and use whatever Kafka client you prefer, even Java. A few years ago, when we tried to use Kafka with Node, the performance wasn't satisfying. So we used the sidecar pattern. A sidecar is the second container, which contains the logic needed by the main container in order to function correctly. In our case, it's the Kafka client. So we use the Java Kafka client inside a sidecar container, alongside the main container, which contains a Node.js service, and the two of them communicate with each other using a gRPC protocol. Why do I like this solution? Because you can write services in Node.js and use whatever Kafka clients you prefer. But this solution is not perfect. Using it, you need to maintain multiple services for each service you deploy. And they share the same pod resources. And of course, you add latency. For each produce or consume event that arrives from Kafka, you need to pass through the sidecar first. So next time you start asking questions about a better way of doing things, and everybody tells you it just isn't done, remember that everything is possible if you are a developer. The main thing is that what happened to millions of Israelis in the passport catastrophe will not happen to you when your product gets a lot of traffic. Set your goals. Figure out what are you trying to test and prove to the world that it can be done. And you can use Kafka with Node. Thank you. Thanks again. Scan the QR code to get the GitHub repo with all of the code we saw today. And of course, we are hiring. Come and grab a beer in our booth outside. Thank you very much.